Hello everyone, my name is Aruhi and welcome to my channel. So guys, in my today's video I'll show you how to detect, track and then count the number of objects using YOLOv8 and DeepSORT algorithm. So this is my GitHub repo. You can clone this GitHub repo, okay, and all the code which I'm going to show you today, everything is available in it. DeepSORT code is available in this folder, and the Jupyter notebook which I'm going to use in my today's class is this, okay. So now let me open my Jupyter notebook and then I'll show you how it works. So guys, the first thing is you should have the right versions installed. So I'm just showing you the versions which I am using so that you can have the same versions and try the code, okay. So the Python version is 3.9.10 and the Ultralytics version is 8.0.106, and you can install this Ultralytic package by writing pip install Ultralytics. Okay, so this is how you can install this package. And why we need this package, because we are using YOLOv8 and you can get this YOLOv8 requirements from this package, okay. So this is the version I'm using, and then the torch version I'm using is 2.0.1 and it is compiled with CUDA 11.7, and the GPU I'm using is this RTX 3090. So guys, if you are working on CPU, then you will install a torch version which is compatible with CPU, and if you are using GPU, then you have to see which CUDA version you have in your PC and then install the PyTorch version as per your CUDA version, okay. So these are the versions you need. And then now let's start our work, and we are entering in this folder first. Where is this folder? Let me show you my code. So basically the Jupyter notebook which I am showing you is this. So this is the Jupyter notebook I have provided you over here, okay. So I'm just entering in the folder where I have my other files, okay. So just import all the required modules. So in my first cell I'm just showing you how we use YOLOv8, and then once you perform detection with YOLOv8, then how to get the bounding box coordinates in a separate variable, then how to get the confidence scores in a separate variable, these kind of things, okay. Because we need these variables like the bounding box coordinates in the classes and the confidence scores while working on a tracking algorithm. So that's what I'm doing here. So I'm using this pre-trained model. So guys, in my today's class I am working on a person class. What I'm doing today is we will detect a person and then we will track the persons and then we will count the number of persons in a video, okay. So this person class is already available in the pre-trained model, the Coco pre-trained model. So that's what I'm using. So I have I'm using this pre-trained model, and then I'm providing this image to the model. Save true means the output image with the detections will be stored in the runs folder, okay. And this is how you use this YOLOv8 model whenever you want to perform detection. And then this over here, what I'm doing is, in this results folder we have the output generated by our YOLOv8 model. So I'm just having the classes in a separate variable, bounding box coordinates in a separate variable, confidence score in a separate variable, and then I'm just showing you over here. So these are the different classes we have detected in this particular video. So now let me show you this image first, and then I'll show you the output image. So our output image is in this folder, okay. So let's do that. So the image is person.jpg. This is the image, okay. After detection you will get a runs folder. Inside that detect and then predict folder, and here you can see the output image, okay. Now this is how we use YOLOv8. Now we will use DeepSORT algorithm. So first we are importing all the required files from the DeepSORT folder. Which DeepSORT folder? Here. In this folder we have all the files and folders. So what we are doing is we are importing it, and this is the pre-trained weight file of DeepSORT, and this also you will get in that folder only. And here DeepSORT, we are providing the DeepSORT weights over here. Which weights? These weights, okay. And the max age is 70. Now guys, this max age parameter is very important. So max age is a parameter that controls how long a tracked object is considered valid if it is not detected in consecutive frames. Okay, so this max age parameter defines the maximum number of frames an object track can be maintained without corresponding detection before it considered expired or dead. Okay, so setting max age value too high may result in the tracker maintaining tracks for too long even when objects have left the scene or are occluded for an extended period. Okay, so after defining these two things, now we want to test on this video. Okay, so this is the video on which I want to work. So first we are reading the video, and then we are getting the from width and frame height, and then the FPS like this. And then what we want is, I want to save the output video. Okay, after detection, tracking and counting, I want to save that output video. So for that I have written these two lines. I want to have the output video with this name. Okay, so these are just those lines. And then we have this frames list and this unique track IDs. So this frame list will store the frames, and unique track IDs, we are using it because we want to count the number of objects. So this unique track IDs will keep track. We will store all the unique IDs over here, and then we will count it. Okay, so yeah, from here we are starting the work now. So we are reading, and we are reading each frame, and after that on each frame we are running this YOLOv8 pre-trained model to detect persons. Okay, so over here we are just loading the model. Okay, and here we are defining class equals to 0. That means 0 ID is assigned to person class in COCO dataset. Okay, so that's what I'm doing, and we have defined the confidence value 0.8. so that means if the confidence value is 0.8 or more than that, then only we will have the detections, otherwise we will not have detections. Okay, so you can change this value as per your requirement. And class 0, as I've told you, a person class. And over here I just have a list of all the classes, all the 80 classes of COCO dataset, and here I am just getting the classes and this bounding box details and the confidence scores which we have performed on this video. Okay, so here I'm just converting them into, I'm just transferring them into the CPU, and then we are converting into NumPy because this is the requirement of our tracking algorithm. So that's why we are converting it. And here you can see inside this tracks variable, here we are using the tracker. Which tracker is this? Let's see, where is this tracker? So just go above, and you can see here we have called the tracker from the DeepSORT. Okay, so that tracker we are using over here, tracker.update. What we want to do, the boxes which we have from the detection algorithm, we are passing that, and the confidence score, remember this conf variable here, and here we stored the values of confidences in this variable. That's what we are doing, and then we are providing the frame. Okay, and then we are using the loop. What we are doing over here is tracker will track the objects now. So you can see here it will get the tracking IDs, and then here these few lines are just to plot the bounding boxes, different colors to different objects. Okay, and here we are plotting the bounding boxes on the objects which are there on the frame, and then we are providing the class names to those objects and the tracking IDs. And after that, here you can see unique track IDs dot add track ID. What we are doing here is, from the above code we will get all the unique IDs, and we are storing them here. And then in the person count variable, we are just checking the length of unique tracking IDs. Okay, so unique tracking IDs means if there are 5 or 6 persons in the frame, so every person will get a unique ID. So we will count all the unique IDs, and that will be a person count. So that's what I'm doing here. Okay, so here you can see, here we are writing the person count, and then we are getting the person count value from here, and we are getting the total number of count. Okay, and then we are appending the frames, and then we are writing the output video. Okay, and then we are releasing all the resources. So when you'll execute this code, you will get this kind of output, and you will have a output video. Now let me show you the output video. So output video is this. Okay, let's open this video. So you can see person class 1 is a tracking ID. Here the tracking ID is 4. Here the tracking ID is 3 and 2. And then the person count is 4. Because we have 4 unique IDs, so we did a count of that. We get a unique IDs and then we are displaying it over here. So this is how you can use this DeepSORT algorithm and YOLOv8 to detect, track and count the number of objects. So yeah, that's it guys. I hope this video is helpful. Thank you for watching.